Let's create a frequency distribution table using 8 classes and then create a histogram to display the data shown here in a stem and leaf plot. First, we want to be able to determine the class width using the maximum and minimum values and the number of classes desired. Remember that this stem and leaf plot was created using original data. The first value represented here on the stem and leaf plot represents 78. This is also the minimum value. The number 128 is represented with the digit of 8 here in the stem and leaf plot. This now represents the maximum value. We can use this to find our class width. To find the class width, we are going to take the maximum value of the data set, subtract the minimum value, and divide by the number of classes. Notice this gives us a decimal value, but we don't want to have decimals when we create our classes. What you're going to do when you find out a decimal for a class width is you will always round up. I want to make each of my classes the width of 7 grams. If I don't round up, I will not have a width that is big enough to include all of my data values. I know that general rounding rules say that the 0.25 means I would round down to 6, but I need to stress that simple rounding rules here will not apply. Because if you do that, you will not include all of your data values, and you cannot go above the number of classes that are specified. So when you have a specific data set and you want to use a formula to find the class width, here's the formula you're going to use. Take the maximum data value, subtract off the minimum data value, divide by the number of classes, and no matter what the decimal value says, always round the answer up. And also, don't forget the units. Again, we are working with weight in grams, so my class width is going to be 7 grams. Next, I'm going to make my frequency distribution chart. This is a 2-column chart. On the left are going to be my classes. My classes are represented by the weight of kittens less than 1 week old in grams. On the right-hand side is my frequency. The frequency in this case are the number of kittens. In order to create this 2-column chart, I also now need to start my minimum value as my lower class limit of starting at 78. Since my class width is 7, that means my lower class limits will have a value of 7 added to each of them to get to the next class limit. I continue to add 7 all the way through until I have 8 individual lower class limits. Now it's time to create my upper class limits. This is a number line representing grams. I cannot have any overlap in my classes, and I also cannot have any gaps. To end my first class, I'm going to end that at 84 because my next class starts at 85. If I go to my third class, which starts at 92, I'm going to end the class below that at 91. Remember that your upper class limits must also have the same class width as your lower class limits. So 84 to 91 has also a gap of 7. To find my upper class limits, I can now add 7 to each of these to find the rest of my upper class limits. So you can see all of my lower class limits differ by 7 grams. All of my upper class limits differ by 7 grams. There is no overlap and no gaps. Now I can take each of the individual data values off of my stem and leaf plot and put those into my classes. So when I look at the number 78 to 84, that particular class, I need to look at my stem plot and figure out how many of those individual data values will fall in that class. 3 data values fall in that class: 78, 84, and 84. Those are the only 3 that fall into the class category from 78 to 84. I need to do the same between 85 and 91. So I have 1, 2, 3, 4, 5 data values that fall between 85 and 91, because the next data value starts at 92. As you move through your stem and leaf plot, you're going to count the number of data values that fall within the classes that we have then created in our frequency distribution chart. For example, the class 113 to 119 starts at 113 to 119. There are 3 data values that fall within that class. Once we have our frequency distribution table, we can now make our histogram. Remember that your horizontal axis is going to be your classes, in this case representing weight in grams, and my vertical axis is going to be the frequency or the number of kittens. Sometimes you will not have enough room to be able to write an entire class, such as 78 to 84. So in this case, we could use things such as midpoints or class boundaries, which is a single point, to be able to label our graphs, which represent portions of our number line. For example, the class midpoint of 78 to 84 is the number 81. So if I want to create a bar that represents the class from 78 to 84, I can simply label the midpoint of that class as 81 instead of the entire class of 78 to 84, as I've done previously. In fact, I can label the midpoint of each of these classes. Once we have done that, we can then create the bars that represent the number of kittens for each of the classes for the weight of kittens less than 1 week old in grams. Remember that the individual tick marks you see here are the midpoints for the weights of those individual classes. For example, when you see the number 116 here, that represents the midpoint of the class 113 to 119. That class is the weight of kittens less than 1 week old in grams, and the height of that bar represents the number of kittens that fell in that weight category.